The tides are a consequence of gravity and acceleration. To picture this, picture a planet falling into a black hole. It's falling straight in, so it's not orbiting. And you can see here, the side that's closer to the black hole, there's a smaller radius from the center of the black hole, so there's more gravity. And on the other side, on the opposite side, there's a larger radius, so there's less gravity. And the whole planet accelerates with the center of mass. The whole planet accelerates at the same rate. So the question is, both sides bulge away from the center, and why is that? So if you picture the planet falling into the black hole, you can see that easily that the bulge on the side closer to the black hole forms because there is more gravity at that location. And it's harder to understand why there's a bulge on the other side, but I have it explained out here. The bulge on the far side forms because the planet is accelerating faster than the black hole's gravity is causing the far side of the planet to accelerate. So seeing how there's less gravity, the whole planet has to accelerate at the same rate. So the far side of the planet is being forced to accelerate with the whole planet by the planet itself. The far side is being dragged along. It, in air quotes, wants to accelerate more slowly than the rest of the planet. The bulge forms as the far side is being left behind, essentially. So you see there's more gravity, so this side bulges out. There's less gravity, so this wants to stay where it is in relation to the center of the mass, but the whole planet is pulling it along. So it's being left behind, so it bulges away from the center. And the same situation develops with Earth's tides. So if you look, the Earth and the Moon have a common center of mass around which they both rotate. So the Earth rotates around this center of mass, which is actually inside the Earth. So the Moon's gravity, if the Moon's away from the Earth on this side, the Moon's gravity is pulling the surface of the planet. It's pulling the water. Well, it's not pulling the water, but anyway, so the Moon's gravity is greater on this side of the planet, and there's also the rotational acceleration, because since this side is away from the center, it's being forced away this way from the center. And on the other side, the rotational acceleration, since this side is much farther from the center of rotation, is much, much greater than it is on this side. But the Moon's gravity is less, and on this side, the Moon's gravity actually contradicts the rotational acceleration. So when you look at both these and add them together, you get the same size of acceleration in these opposite directions. And both arrows contradict the inward gravity of the Earth. So you're actually, when you have high tide, you're actually a little bit lighter. And what's happening is on these two sides, where the Moon's gravity and the rotation cancel each other, so there's no tidal accelerations on this side, the Earth's gravity is squishing the water like this. And these arrows here, these forces, are canceling out Earth's gravity a little bit, so that you're actually lighter here, and Earth's gravity is greater here and squishing the water away, so that the water forms bulges here. And it's still really difficult to understand why that there's a bulge on the other side, but the whole reasoning is that since the Earth's rotating around this center of mass, there's that rotational acceleration, which it's like if you're standing around spinning a bucket around, you have the bucket force. People aren't going to understand that, are they? Okay, so basically, the Earth has to stay together, and the Moon's gravity is pulling on the surface of the Earth, and it's pulling this part away, but it's also pulling over here. But there's a bulge over here because as the Earth rotates around this center of the mass and the moon, in order to keep this from flinging off as it rotates, some of Earth's gravity, it has to keep the planet intact, which is why you have the rotational acceleration in the opposite direction. It's the centrifugal acceleration.